Hello everyone, this is Ujjwal Gandhi from Spatial Thoughts. This is an extended version of the talk I gave at the FOSS4G 2025 conference in Auckland, New Zealand. Since there was a lot of interest in these topics, I pre-recorded a version of this before the conference and I'm sharing this right now. Hope you enjoyed the talk and look forward to hearing your feedback in the comments. This is a talk focused on QGIS Model Builder and how you can use this to automate your workflows. If you want to get access to this slide deck, here is the QR code and a bit.ly link. There's a lot of materials in the slide deck which will give you access to the full case studies, all the step-by-step instructions. So either you note down this bit.ly link or take a photo of this and you'll be able to access everything that I'm showing you today. The plan for today is I'm going to talk about what is possible using the QGIS Model Designer and show you how far you can push this to create some really interesting and complex automations. We have 3 case studies. These are all based on real projects that I've worked on. And again, it's going to show you different parts of Model Designer. There are some new features that I'll show that have been implemented recently, which if you've not been keeping track of what's happening with QGIS, you may have missed. The QGIS Model Designer is intended as a no-code solution for QGIS users to build workflows. Here you can drag and drop different algorithms, chain them together, and define what inputs you want, what outputs you want, and you can build a workflow. And that means if you have 10 different steps in your workflow, you can chain all of them together. And when you run your workflow, all of them get executed in the order that you configured. The advantage of this kind of tool is that it's much more accessible than other options. You might be able to achieve the same thing, maybe using Python and GeoPandas and other solutions, but that requires coding, people to understand how to set up your environment, how to run this. This runs within QGIS, and that means anybody who's familiar with QGIS can run these models, can maintain these models, can edit this model, and so on. So it's a kind of good first step for automation for a lot of the QGIS users. And as you'll see today, that it's really powerful. It's not a very simplified tool. It has got a lot of advanced capabilities, and you can really do something very advanced without actually diving into code. So let's see some of those examples and what you can do with this. The first one is kind of an interesting one. When you think about Model Designer and Processing Toolbox, you're thinking about analysis. Many of you would have used this to say, I have this analysis that I want to do. I want to do some buffer and intersection and do some field calculations. I can automate that. But what if I need to automate creation of maps? That is something you don't kind of relate that the Model Designer will be able to do. So when a project came along where the user said, I have this task, I come to office every day, I'll go and download some data, I load into QGIS, I do some processing, I'll apply some style, make it look nice. I have a print layout that I have configured. I need to kind of use the print layout, add this data, and save this map on a shared drive. And I need to do this every day. Can we automate this? And I said, sure, you can, for the analysis part, you can automate, but what about downloading data? What about creating this print layout and rendering maps? Can we do this automatically? And we say, why even you need to come to office? What if you're on holiday? Who does this? So can we just automate it completely where you don't even touch it and a new map gets generated every day? And everything needs to be done within the QGIS environment. So how can we make this happen? This was the kind of workflow. The idea was there is some data set which detects fires. And the goal was to create a map of active fires within the continental United States every day. So there is a data set called FOSS4G, which gets updated. It's a near real-time data. You go and download the zip file from this website and it'll tell you where were the fires that were detected in last 24 hours. So every day you go and download this data. This data contains data for like the entire Western hemisphere. You clip it down to US, then you say, I'll style them because you have these points. You need to style them in a nice style that you have configured. And then you need to have a map template which has a logo and the place where the map goes. You need a title. You need to say this map is for this date and so on. And then finally, the map has to be saved in a shared drive so that the other people who want to use it, they can go and use this. So this was the workflow that we had to automate. Let's see what are the tools in your Model Designer that can help you do this. The first one, which many people do not realize, that there is a built-in data download tool in your processing toolbox. If you have a public URL that you want to fetch, you can use this download file algorithm where you can say, this is a URL, go and fetch it. QGIS will fetch it and save it to a local file. That means in your model, if you're downloading data, this is a great tool to have. you doing this within the QGIS has many advantages. What if you have a firewall that you configured in QGIS? If QGIS can access it, you will be able to access it. So you don't need to go and implement those firewall settings in your Python environment, etc. What if you want to get some private data? There's another tool in the toolbox called HTTPS post and get request. That means if you have an API that is giving you private data, you can configure your authentication options in QGIS and then have QGIS fetch the data for you. And this solves so many of your data problems. If you've been writing some Python code or you have some tool that goes and fetches some data from API, you can now just put this as a workflow step in your model in QGIS. And that's immensely helpful. So here we just have a public URL. So we use this download file and get the latest file. So when you run the model, you'll just go and fetch the latest file. The next step is some data pre-processing. Here, you can just use any of those built-in tools to apply any spatial or geoprocessing steps here. So here, in this case, we just clip the data to the region of interest. And there's a tool called extract by location. We'll just find all the points that are within the region of interest and create a new layer. This one was also a tricky one. How do you apply a layer style? Like you have styled this fire points in a specific style. Let's say you have a custom icon and you have a particular size and labels. How do you kind of specify all of that? The simple way to do this is you first do this once in QGIS. You do all your styling, right-click your layer and save the style file as a QML file. This is a QGIS style format where you say, here is a layer type, point layer, and here's my style file. You'll apply that and the style captures everything that you've done to that layer. So now you have this QML file. There's a tool in the toolbox called set layer style. That means if you're running a model and you have an intermediate layer, you can just say, here's a QML file, go and apply this. And the layer will get styled based on the style that is chosen. So now you can think if you're doing some cartographic work and you want to automate this, well, you have a bunch of QML files and you can use them in your model using this tool. So now we have this fire points, we apply our pre-configured style, and we have a style layer. Next, we want to create a map. So QGIS has a tool called print layout, where you can create a layout. So here we create a layout. There's a place where the map goes. So the place where the map goes will be updated with the new data that we have. Other parts, you can have a static titles, you can have a logo, you can have other elements. If you want to have something that is live, you can use variables. So for example, here on this map, you want to say this map was created on this date. So there is an expression such as now, which will just say whenever the model is running, what's the current timestamp? It's going to get that timestamp and replace that part. So again, use expressions where you want stuff to be replaced using the data or the time of the model that was run. And then you create a layout. Again, this can be saved as a QPT file, which is a QGIS template format, or you can just save it in a project. So you have a QGIS project and say, here's a template that I want to use, and you can save that in your project file. Once you have the template, there are tools in the toolbox. Again, many of you would not even know that these exist. It's been a few years since they've been added, where if you have a layout that you saved in a project, you can now render that using new data. So you can say, I have this template called fire, which I want to render now. So you can say, here's a new template. Here are the layers I want to render on that. So in your model, you were processing some layers, you style them, and now say, here, take those layers and render this layout. And it'll generate a PNG file. You can also generate PDFs. And that means you now created a map automatically through a saved template and through a saved style. Once we have a map, we can just chain all of this together. We have figured out how to go from the data download to creating a map all automatically. And again, this kind of model needs a QGIS project, right? Normally, if you have a model, you can just say, give it to anybody and they can run it. Here we have our print layout saved in the QGIS project. So a good practice that we always recommend is when you save a model, typically when you save a model in QGIS, it's saved locally on the computer. Instead of that, always save this using this button, which is saving the model in your QGIS project. And that means if you have your QGIS file and anybody you send the file to and they open it, they'll have the model. In the processing toolbox, there'll be a folder called project models and your model will be there. And that means you'll not lose the model regardless of the system that you're working on. And since our templates and style, everything is in the project, it kind of has all the data that you need to run the model itself. And let's test it. So now we can run the model, and you can see you can run the model. It goes and fetches the data with the current live data from firms. You can, as a processing, it renders the print layout and generates this PNG file. The way the model is configured is we specify an output folder. And this could, in the demo here, it's a local folder, but it could be a shared network folder. And that means when you run it, the output file is rendered on that particular shared folder. It's named firemap_today's date, right? So every day when you run it, it'll just automatically put that PNG file with the current fire data with the correct name on that shared folder. So now, instead of coming in, doing this manual work, you can just run the model. But can we take it one step further? Can we now even run this model automatically? Let's say every morning, 6 o'clock, I want to run this model. How can we do this? So we have a model, we have automated this. QGIS, and this is the map that was produced by the model. But now I want to generate this automatically, even without me being present. I have a machine with the QGIS installed. If the machine is on, it should automatically start the process of fetching the data and doing this data processing automatically every day at 6 o'clock. How do I do it? QGIS comes with a command line tool. So all of you who have installed QGIS in a system, you have a command line tool which you can run from a terminal. Be it on Windows, Mac, or Linux, you can open a terminal and type this command called QGIS process, which will allow you to run any processing tool or a model from the command line. And this doesn't need QGIS to be running. It just runs it in headless mode. That means you can just type this command, give the path to the model, give the output path and all the parameters, and say, here's my project file, run it, and it'll just run the model autonomously without you doing anything. So now we've figured out how to run this model using a command line. We have a command that needs to be executed on a schedule. Depending on an operating system, on Windows, you can go to Task Scheduler, paste this command line and say 6 a.m. every day, run this command line. And it'll run automatically every day. When you come to the office, you'll have a new file sitting in your shared folder. On Mac and Linux, you have a cron tab, which you can configure this command line and it'll run. Doing this, we didn't have to do any coding in Python, or we didn't have to know any kind of system administration or data engineering. We just use the QGIS's built-in modeler tool and the command line tool. The command line tool has a lot of features. We have a detailed blog post on how to access this tool and how to use it. It's linked from the full case study link that you'll see in the end of the presentation. That's the end of the case study. Again, it's hopefully gives you an idea of something that if you have a full project workflow, how can you automate this using the modeler. At the end of each case study, I'll give you a little tip. There's a little tip that when you're working with a model designer, if you're like me, I am very picky. I want everything to be aligned perfectly in my model. And if you've been doing this by hand and wasting a lot of time, there's a new option in your model designer where you can select a whole bunch of sections and say, please align them, and QGIS will align them to a grid. Small thing, but again, if you really like everything to be nicely organized, this will help you keep those organized. So after looking at how we did the automation of map creation, I want to share some of the features in the model builder that allows you to do conditional processing. This is often a requirement when you're doing your automation. You say, if the user selected this, do that. If the user picked this layer, do that. Or if during the model, if you reach certain condition, do this, otherwise stop. Right? How do you implement this kind of conditional logic in your model? Here in this project, it was like a site selection project where you say, give me a bunch of layers, I'll figure out what's the optimal site to locate this. This is a simplified version of the project just for easier demonstration. Here we have just a couple of layers and say, based on what layers were provided, you do different operations. So for example, you say, I have a building and a boundary layer. Find me all places in the region which are 50 meters away from a boundary, and find me all buildings that are 50 meters away from the boundary. Simple as that. But if the user also gives you a road, then you also find all the buildings that are away from boundary, but also away from a road. Right? So you have buildings is required, boundaries required, but roads the user may or may not give. Now, this is a conditional logic that we want to implement. in your kind of traditional flow, it will be hard to do this because you say, I expect you to have a road or not. How do I implement this kind of conditional thing? There's a tool in the model designer called conditional branch, which is available only in the modeler. So if you go to your main QGIS toolbox, you won't see it because this makes sense only in the context of a model. So here in the conditional branch, you can specify different conditions. And whenever the condition is met, the model will branch into the separate branch. So here, for example, we can use the variables. When you create a model, each input or each intermediate layer has a variable assigned to it. So here we say there's an input called roads. The model will branch out here. If the road is not null, it'll do something. If the road is null, it'll do something else. And now I can specify what happens in each of those cases. So I don't need to hard code my model. I just say, whatever the user says, take a different approach based on that. Here's what the completed model looks like, where you have some steps which are done. So you say, I have the boundary. I always need to find all the buildings which are away from boundary. So I'll do that. Then I'll check whether the roads were provided or not. If the roads were not provided, then I'll just find the intersection of the buildings that are away from the boundary, and that will be my result. If the roads were provided, then I'll also compute my buffering of the road, compute an intersection, and that will be my result. So I can implement a branch in my model that'll do different things based on the input that were provided. Let's see how the model works. Is an example, we specify boundary and buildings, keep the roads as empty. So the model runs and it'll generate something. Now we select roads and run it again. It'll give me a different output. The model is the same, but because I gave an additional input, it branched out and I got different results based on that. So if you have a need where you need to do different things based on either the inputs or some intermediate condition, you can use this conditional branch in your model to do this. And you can have multiple branches. You can say, first check this, if not, check this another condition, and so on. You can implement as many conditional branches in your model as possible. One pro tip when you're using this conditional models, if you have a very complex workflow, it is good to build a model for each use case. So let's say if this was a very complex workflow, you build a model that will say, I'll take roads and buildings and do something. That will be one model. There'll be another model that will just work with buildings. And now when you have a condition branch, you can say, when you meet this roads condition, call this other model. So you can call a model from a model. So it'll make your code much more modular, where you can just implement the workflows as models and import them in your models. And it's importing as simple as adding a model as a step instead of an individual algorithm. And that'll make it much more easy to maintain, where instead of having a 50 steps condition branch, you just have one step, which is calling the model, which internally does those 50 steps. That's it for this case study. I'll share one more tip. This was a bit annoying thing for a while in the model builder. When you run your model, the order of the inputs and outputs was fixed. So when you run the model, you have some order of the model which were not logical. And it was very hard to kind of make sense of this. So now there's a new feature in the model designer where you can change your order of your inputs and outputs using this option. Now you can say, I want my input points to be the first one, the base layer to be the next one, grid size to be the next one, and it'll appear. A small thing, but again, something that any of you, if you used it a few years ago, this was a bit of small annoyance that is now fixed in the model design. In the next case study, I'm going to show you a workflow which was implemented for a client who had this requirement of automating a really tedious manual task. And at first glance, when you see the problem, it seems very complex, something that you probably won't use QGIS to implement. But then we decided to do this in QGIS. We were able to do it, and it was a really good decision to do this in QGIS compared to doing it in Python. And I'll come to the reasons why. But I'm going to show you how far you can push the kind of QGIS and processing tools and expressions to do something, automate something that was really, really difficult. The problem was to automate this process of validating rainfall data. The process required that when you receive this data from rain gauge stations, which you get periodically, the rain gauge stations may be malfunctioning, there might be some problems, there might be some errors in those readings. Before you use them for analysis, before you use them for predicting floods or using them for insurance purposes, you need to make sure that the data is valid. And this organization had a very detailed validation process where you had to take each observation that you receive for each of the stations. For each month, you had to sit down and validate this. And somebody had to do this, like this very complex calculation every month to validate this data. And imagine you had like thousands of stations. You can't possibly do this manually for all thousands. So they would just pick randomly a few and check. And again, that was not ideal. So again, idea was, can we automate this process? The validation process looked like this. Let's say you have a rain gauge station, which said in this rain gauge station recorded 30 millimeters of rainfall in this month. Is this correct or not? Now, how do you validate when you have this is your ground truth? So how do you check? Well, the one simple way to check is what was the readings of the neighboring stations? Rainfall is kind of a spatially homogeneous process. That means if it rained at one station, it would have rained something similar in the neighboring station. So you'd go and check what was the readings at neighboring stations, and then you'd compare the current reading with the neighboring reading and say, if this was 30 millimeters and the neighboring station said 300 millimeters, then this station is malfunctioning. That was the basic concept. But to do this, they had this process where they say, oh, you just can't pick any random stations. You say, I'll pick a maximum, a station which is within a limited distance. So you say, I'll pick a nearby station within the 10-kilometer radius, but I'll pick 8 stations, not just one, because what if I picked a station and that was malfunctioning? So I'll pick a total of 8 stations within 10 kilometers and do an inverse distance weighted comparison. But again, what if all the stations were in one direction and maybe there is a mountain here that was kind of blocking the rain and it was very different here. So I want to make sure robust. I'll select at most 2 stations in each quadrant around this. So now I have to pick 2 nearby stations in 10 kilometers within each quadrant with a maximum of 8 stations. And I need to do this for every station and then implement an inverse distance weighted interpolation to find what was the interpolated rainfall compared to the current rainfall and compare them. Again, this seems very hard and impossible to do, but with QGIS expressions, we are able to kind of implement this within QGIS. The key to solving this was this function called aggregate expression, which allows you to find neighbors. We have multiple posts where we have demonstrated how to use this function to find neighboring features. So you have a polygon and say, I want to find all neighboring states to the state, or I want to find the neighboring zip codes to each zip code. You can iterate through your neighbors and find the list of neighbors. So again, you use this to say, I want to find all neighbors for each station and give me the names of all the neighbors within the certain distance. But we can also implement this condition where we can say, I want to find all neighbors which form an angle of 0 to 90, which is your quadrant 1 neighbors. So we can also add a condition to the expression and say, draw a line between each station, measure the angle between the station and the neighboring station. If the angle is between 0 and 90, that's quadrant 1. And now you will be able to find n number of neighbors to each station within each quadrant. So that kind of quadrant condition was solved using this aggregate expression. Once we had this list of neighbors, so you can see these are all the neighboring stations to each station in each quadrant. Then we need to go and compute the distance. How do you know the distance from each station to each of the neighboring stations? If I give you 2 points, there is a function called distance that you can run in expression and look at the distance. But then for each point, I need to iterate and say, I have 8 neighbors, run this function 8 times for each of these neighbors for each feature. And there is this really nice array for each function where you say, I have a list of neighbors, run this function 8 times for each of those neighbors. So this function was used to iterate over each of those neighbors to find the distance. And once you have all the neighbors, all the distance between them, and all the rainfall, you can implement the inverse distance interpolation. And then you find the expected rainfall at the station, the measured rainfall, and there was some condition. You measure the standard deviation, and if the deviation is more than certain threshold, you mark this station as a suspect, saying the neighbors have a very different rainfall than this thing, so go and check that rainfall. Once we implemented this, it was all just expressions, but they were implemented at each expression that you can run through the field calculator. So at each step you create a new layer, adding a new field based on each neighbor, compute the distance, compute the standard deviation, compute the rainfall at each of those things, get the inverse distance weighted rainfall, and finally compare and flank the stations. So each of those steps were implemented as a field calculator algorithm in the model builder. And when you have it, this is what the final model looks like. So here we have hundreds of stations. You can see there are 600 stations. Imagine you were the analyst who had to validate this every month. Here's the 600 stations and all the rainfall. Go and check each station against all of these 8 neighbors in each quadrant. It's a nightmare. But now you have a model. You can run that model and say, I have this new data. Here are the stations. Here is the measured precipitation. Here is the name of each station. Go and run this. And when you run this, it just runs this process. And you can see within just 1 second, you have the full computation. And now you have marked each station as valid, not valid based on this condition. And you can go and check and say why this station was flagged as suspect. And you can go and either remove it from an analysis or go and see in more detail what happened there. I want to end the talk with a last tip. This is something that has been on my wish list for a long time. It finally got implemented in QGIS 3.38, which is, imagine you have a model with 100 steps. You run it, it takes like 30 minutes to run, and you got an error on the 99th step. And say, oh, I fixed the error, and you run it again, you start from step 1. But now QGIS Model Builder caches all the intermediate results. And that means once you run a model once, you can now rerun the model with only selected steps. So here's an example where we run the model and say, oh, I made a mistake in the last step. I need my field name to be something different. So I change my field name, but I don't rerun the whole model. I just say, I just want to rerun the last step. So you select the steps that you want to run, and there's a new option in the model builder, say run selected steps. And you'll only run that step because all the previous outputs are already been cached, and it uses those. Super helpful when you're building models and debugging this. It saves you a huge amount of pain when you are testing stuff. So do use this whenever you are testing and building models that you can partially run the models now. If you're curious about any of these use cases, I have documented this in detail with all the steps and all the final models with the sample data sets that you can use it to reproduce that. You can use those links to read the full case studies. If you're curious about the model builder and what you can do, you might also be interested in our new workshop, which we just finished building today, which is using Earth Engine and QGIS together for building workflows. So there's a new plugin, Google Earth Engine plugin, which now allows you to fetch data from Earth Engine in QGIS through Model Builder. So you can build models like this, where you can say, I have a data in Earth Engine. I can just specify the data ID. I run it. It processes and exports the data for the region of interest, and then you can use the data in QGIS. This model that you see on the screen fetches a land cover data and computes the area of each class within a given region. And again, you don't have to download any data. It just fetches that from Earth Engine. So if you're curious on how to do this, do check out our workshop. It's linked here, and you'll be able to see how to use that plugin.